For number 6, we have data here, and we are going to conduct a hypothesis test and do a confidence interval. First, with the hypothesis test, we need to make sure we have a null and an alternative hypothesis. A null hypothesis has to have a statement of equality in it. So we'll always have a null, our null hypothesis will always have an equal sign in it. And now to find the p-value for our data here, first we would want to open it in StatCrunch. And notice that we have paired data here. This is a dependent sample. There's 8 separate observations, and for each observation we have our 2 samples, or our 2 pieces of data, one in each sample, and they're paired up nicely here for each observation. So we have 8 pieces of paired data. If we go to stat, t-stats, we would want to go to paired. And our first sample is listed in that column. Our second sample is in the other column. Our hypothesis test is that the means are equal to each other. So the difference of the means, if you subtracted them, you would get 0. And then our alternative was a less than. So we hit compute and we can get back the p-value. Depending upon if the p-value is, if it's less than 0.05, our significance level, alpha. If it's less than that, we reject the null hypothesis. And if the p-value is larger than 0.05, which is our significance level, then we do not reject the null hypothesis. For this particular example, 0.02 is less than 0.05, so we reject the null hypothesis. Now we can compute a confidence interval with that same data. So going back into StatCrunch, I can actually just, to the same place you went, this time instead of clicking on hypothesis test, change it to confidence interval. And I 95% confidence interval, I hit compute, and you get the lower limit and upper limit of your confidence interval. And I just want to mention that this result supports our decision to reject the null hypothesis because both our upper and lower limit are both negative. So we have 95% confidence that the difference between our 2 population means is negative, somewhere in between this lower and upper limit. And that's our alternative hypothesis, that the difference is less than 0 or negative. So these 2 decisions to reject the null hypothesis is also supported by our confidence interval, which also suggests that the difference is not equal to 0. It's actually a negative value in between this upper and lower limit. For number 7, we're looking at another situation with 2 samples here. This time we're firing a gun and measuring the muzzle velocity, how fast the shells are being fired. Now we're using 2 different recording devices on every single shot that's fired. And so we have nice paired data again. For each of these shots that are fired, there are 2 measurements, both taken on that same round that is fired. So that is why this is a matched pairs data, why we have dependent samples here. And so once again, we're going to run a hypothesis test and construct a confidence interval. So I want to open this data in StatCrunch. And when it loads in StatCrunch, I can go to stat, t-stats, and paired data. And then my observation, sample 1, column A, sample 2 is column B. And so we're trying to test if there's any difference at all. So we need to have the correct null and alternative hypothesis. Our null is that there's no difference between our averages here, that the difference of the means is 0. Our alternative is that there is a difference, and we want to, with alpha of 0.01, and we get a p-value back that is much larger than 0.01. And anytime your p-value is larger than your alpha, you do not reject your null hypothesis. And then I want to also do a confidence interval. So if I go confidence interval at 99% confidence interval, I'll get the lower and upper bounds of our confidence interval for the difference between the means. And so we can be 99% confident that the mean difference is somewhere between these values, and notice that our lower limit is negative and our upper limit is positive. So that means 0 is an option within our limit. So it is quite possible that the difference between these means is 0. And so this again just supports our same decision that we made with our hypothesis test. We don't want to reject the null, which is saying the difference is 0, based off the p-value, and we also don't want to reject it based off of our confidence interval, because 0 is an option within our confidence interval. And number 8, we have another dependent situation. Someone's testing water clarity, and they have their observations here. They're making them on the same date. They do an original observation, and then they do one 5 years later on that same date. So we have nice paired matched data from a certain year and then that same date 5 years later. So once again, we want to open that in StatCrunch. And if we go to Stat, T-Stats, paired, we can then conduct the hypothesis test. And so we do need to make sure we understand what our null and our alternative should be. So if we looking at here, the researcher wants to know if the evidence suggests that the clarity of the lake is improving at this level of significance, 0.05. So our null is going to be equality, that there's no difference between the mean clarity in our water samples between the original year and 5 years later. So there's no difference, a difference of 0. So how would we show improvement? It would mean that our clarity is actually higher, better 5 years later. So we're getting bigger numbers back 5 years later. So that subtraction would lead to something less than 0, because our second sample has larger numbers, higher clarity than our first. And so let's compute that. We get a p-value of 0.03. So that is less than our significance level of 0.05. Anytime we're less than that level of significance, we reject the null hypothesis. So we're going to reject it, which in this case is a good thing, because we're rejecting that there has been no change in water clarity. And we're accepting the alternative that 5 years later, the water clarity is actually better now. For number 9, we're looking at fathers and sons and comparing their height. The belief here is that sons are taller than their fathers. So first we need to think about what our null and our alternative hypothesis will be. Our null is going to be equality again, and there's no difference between the mean heights. So that when you subtract them, we get 0. Our alternative, and it tells us here how to do our measurement, would be the son's height, which if you click here, you can again verify that the sons are the y and the fathers are the x's. So the son minus the father is the difference we're looking at. And so if we're testing if the sons are taller than the fathers, this subtraction here should be positive. And so that's why we have a greater than 0 for our alternative hypothesis. This will be another case of paired data. We have dependent samples here because we're looking at a father and a son. So we have a paired up relationship between our samples. We'll want to open that data in StatCrunch. And again, go Stat, T-Stats, paired. Now, we want to remember we're doing this subtraction of the son minus the father. So we want the height of the son to be sample 1 and the height of the father sample 2, so that when it matches up with what we're seeing here in StatCrunch. And we're looking for the greater than as our alternative. So we do that back and we get a p-value of 0.32, and that is going to be larger than our alpha of 0.1. Anytime p-value is larger than alpha, we do not reject the null hypothesis. There's not sufficient evidence to reject it and assume that the alternative is true.